Hello. 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 Am I audible? Uh, Hello, Atharva, Narendra. Anybody? Can you hear me?
Hello.
Yeah, Atharva, can you hear me?
Yeah, yeah. There was
Uh,
supposed to be the doubt clearing session at 6 o'clock, like the
no,
problem solving.
it is from 7 to 9.
Okay, okay.
Yesterday it was 6 to 8, I think. Uh, so today it will be 7 to 9. Uh, we'll try to wrap it up as early as possible. Don't worry about that. Uh, Before we start, can you just confirm if you can see my screen?
Yeah, yeah.
Okay. Uh, and there is no issue with the voice, right? I mean, you can
No,
hear it. Huh?
yeah.
Okay, so just give me a couple of seconds. We'll start. Uh, 1 second. Huh? We'll wait for, let's say, 2 3 minutes if anybody else joins. Otherwise, we'll start. In the meantime, I'll just prepare the front page of the slide. Uh, this is week one. There are three people. Atharva is there. Narendra is there, but he is not answering. I don't know what happened to him. Then one person is there, but it is number 1876182103. Anyway, I don't know. There is no name for the third one. Yeah, I think we are good to go. Audio is there, video is there. I mean, screen is there. Yeah, so before we start, I am doing this admit all, but I don't know why every time it is asking me to give the permission. Anyway, so before we start, anybody would like to introduce themselves? Atharva?
Yes, sir. I'm Atharva and I'm from COEP, and I have taken up this course as a MOOC course for my finals in
Okay. Which year you are in?
final year, BTech Mechanical.
Okay. Do you have any elder brother, Ashish Chougule, by any chance?
No, sir. No,
No.
no, sir.
Actually, he was my batchmate in BTech. So anyway, you are
Yeah,
from?
Pune. I'm from College of Engineering, Pune.
No. Like, you
Yeah,
are
I'm from Pune only.
Pune. Where are you from in Pune?
Pimpri Chinchwad.
Oh, I am from Hadapsar. Anyway,
Okay.
so yeah. So basically, I mean, the like as the slide title indicates, this is a assignment discussion. So, but anyway, we'll get over with the introductions first. Atharva, we have done. MK Ansari, can you just introduce yourself? Uh,
Hi, sir. This is MK Ansari from Saudi Arabia.
Saudi Arabia. Oh, we have
Yes,
international
sir.
guests. So,
I'm working in Jeddah, sir. I joined this session to learn about how to resolve the questions and answers.
can you briefly let us know what do you do? Like, what is your job responsibility or something like that? Briefly, no need to go into details.
Actually, I'm working here as a support service supervisor. Our responsibility to hello.
I'm listening.
Okay. Our responsibility to only check the area surrounding everything, the work and the task is going smoothly. Procedural, any correction in the procedural, etc., etc.
Okay, fine. So, your educational background is in which discipline?
Health and safety, sir.
Okay. So, what are your expectations from these discussions? I am just asking so that I can prepare accordingly.
Uh,
Hello. Sanjay, you can stop your video. We can just discuss via audio. Hello. Uh, Ganesh, can you mute yourself? Ganesh and Sanjay, both of you. Yeah. So we were talking to MK. What is your first name, MK? I mean, MK sounds. Hello.
Yes, sir.
Okay, Sanjay is there. Sanjay,
Yes,
can
sir.
you introduce yourself briefly before we start?
Yes, sir. Myself, Sanjay Sajjanwar, a faculty from Jhulelal Institute of Technology, Nagpur. Sir, I am from Mechanical Engineering,
Hmm.
Assistant Professor.
Oh,
And
good.
in this college, I am from 6 years. Since 6 years, I am teaching the subject of Mechanical Engineering, manufacturing process and machining processes, and advanced production processes. All these
Oh,
subjects
so
I'm first time joined this production subject.
okay, fine. So, like, do you teach this subject, industrial engineering, or
No,
you
sir.
have not?
Till now, I have not teach this subject. Basically,
Okay,
my
fine.
subjects are related with manufacturing process, machining process.
Okay, understood.
Okay, sir. Thank you.
Yeah, thank you, Sajjan. Then there is Ganesh. Ganesh, can you just briefly introduce yourself?
Yes, sir. Good evening, first of all.
Good evening, Ganesh.
Yeah, my name is Ganesh Kankanala and I am from Andhra Pradesh. I recently
Yeah.
completed my graduation in mechanical engineering.
Mhm.
So I just want to, enhance my knowledge about industrial engineering. So that's the reason I joined this particular course. So
Yeah.
here I am being in this session.
You are doing what, Ganesh?
I'm a student, sir. I recently completed my graduation in mechanical engineering.
Okay. Okay.
Yes.
So, who else is there? Edson joined recently. Edson, can you hear me? If you can, just briefly introduce yourself.
Yes. Good evening.
Good evening.
I'm from Brazil,
Oh, Brazil. Okay.
and now it is morning, 10
Oh,
p.m.
oh,
Uh,
okay.
I am chemical engineer,
Oh, okay.
and I like a lot of NPTEL courses.
Okay. Is my accent okay for you, Edson?
What?
Are you able to understand my accent? Is it okay for you?
Yes.
Yeah.
I I've I've done a lot of courses of NPTEL, and um, I can understand your accent very well.
Okay. Yeah, that is fine. So, welcome you all. I think I have covered everyone. There was Narendra who joined some time back, but he left. He used to join my last class. I used to take some another course last semester, but he left. I don't know why. So anyway, there is one person left whose name is not visible here. It's 18761A, something like that. If he or she can listen to me,
Yes, sir. My name is
yeah,
Tanush Balana. I
yeah.
completed
So
my
you are
BTech Aerospace Engineering.
okay.
I like to do MS in Industrial Management, so I registered this course.
Edson, you can just mute yourself. That will be better. 1876. Pardon. Sorry, I could not catch your name. Pardon. 1876.
My name is Tanush, sir. Tanush Balana.
Okay, okay. Where are you from, Tanush?
I am from Vijayawada.
Oh, so you just completed your undergrad and you are doing masters.
Sir, I'm planning to do masters in Industrial Management, so I registered for this course.
Okay, I think we have very variety of students here. So what I'll do, I'll just get on with it. So before that, let me first introduce myself. My name is Akshay. I am from. I hail from Pune. Born and brought up in Maharashtra, but majorly I was in Pune. Currently, I am doing my PhD from Indian Institute of Science, Bangalore. If you, I mean, I hope some of you have heard about it. Uh, so, and so this is my brief introduction. This Principle of Industrial Engineering course I had done during my BTech days, as well as when I was preparing for GATE exam and other competitive exams like engineering services, civil services, and other government exams like ISRO, DRDO, etc. So, at currently my specialization is in different field, but still I can do justice. I hope I can do justice for you all to this subject. So anyway, the uh, this discussion of, let's say, 1.5 hour discussion is primarily focusing on week one. The I hope everyone has gone through the uh, videos taken by professor for the week one, and based on that, you would have received one assignment which is, I think, due tomorrow. So uh, ideally this discussion should happen after your assignment submission. But anyway, what I'll do, I'll take some different type of questions that will be similar to what you will face in your assignments, but not the exactly same. So that way, it's we can manage that way. So yeah, generally what I do before getting into the questions, the pattern that I follow is because nowadays the human memory is quite fragile. We don't usually remember what we did yesterday, so uh, it's not good for me to expect that you will remember everything that you have done in the last week regarding this course. So briefly, for 10-15 minutes, I just revise the important concepts, what the professor has covered in the class, and then we can just dive into the questions. So that way, it is kind of a refresher. You can revise your concepts for that week, and then we can do some questions also. Coming back to this first week of the course, it was primarily introductory part regarding the upcoming topics that you will encounter later on. So yeah, first we'll discuss briefly about what was covered last week, and then we'll go to the questions. I hope it is okay with everyone, and yeah, let's get started. Just before that, I'll check if anybody has joined. I don't know why it keeps on asking me every time if anybody joins, but I think all are here. And I think Narendra left. Anyway, so yeah, this is first we just do some brief recap. So if you remember, Professor, basically started with what is industry, and the important topic for today's discussion also is, first of all, industry. You should know what is industry. I mean, this is nobody will ask you this anywhere in interview or anything, but you should know. When you mean industry, you are describing an entity, which can be an enterprise or organization that is into the business of producing or distributing goods or services. So that is a brief definition of what an industry is. Then there are categories of industries. One type is primary industries, and one good thing about this course is this course. How should I put it? If you can, logically think, if you use your everyday's knowledge or common sense, which is called as sometimes, if you use those things, more or less, you can understand the concepts in this course, and you'll be able to answer the questions, or maybe for your specializations, you'll be able to use these concepts somewhere else where you require them. So that's what the primary industry. It basically uses natural resources. I hope this font size is okay for everyone. If it is too small, you can interrupt me and tell me. I'll write in a bigger font. But I think this is fine. So, can anybody just give me some example of primary industries if you know?
Oil mining, producing rice.
Okay, that is okay. Then there is agriculture, which is very common. I mean, very influential field, primary industry, because it provides us with food. There are bunch of them. If we started listing them, it will take a lot of time. But yeah, I basically ore mining or crude oil, extraction, those type of things which are directly taken from nature and converted into some usable form is called primary industry. Mariculture is also there. So there are many are there. Then there is secondary industries. So again, as the name suggests, what happens? These industries take inputs from primary industries. For example, if you take an example of, let's say, crude oil extraction. So crude oil extraction is primary industry, but based on crude oil, if you do distillation and if you get petrol, diesel, and the other byproducts of this column distillation, those industries are essentially secondary industries. And for example, one more example that I can think of is extraction of rubber. Rubber from natural plant is a primary industry. Based on that rubber, you make tires or other components. But let's take tires, and those tires are used for different industries like car and all. So tire making is a secondary industry, and then like these make use of outputs of primary industries. Then there is, I mean, if you can count, that it will be tertiary. Tertiary, in a sense, you can say these industries should, like these industries use outputs from secondary and provide the goods or services to the tertiary. But like in common parlance, tertiary sector is primarily in India or even abroad also. You can include this service sector, which is instead of goods, primarily focusing on services. For example, banking or IT solutions, those sort of things can come under tertiary industries. So this was one major important chunk that was covered last time. Then there were minor topics like why do you study industrial engineering? So basically there is a good acronym that professor introduced in the last week's content. Essentially, it's quality, quantity, cost, and time. So essentially, these four things are there. You need to make a quality product. You need to produce the product in sufficient quantity so that the customers can be catered on time, and the cost should be reasonable. If your cost is too much, the competitors will, gain your market share. So basically, this whole thing is about the industries and how they will go ahead as compared to their competitors in the market. Then there was discussion on how do you approach, like when you talk about industrial engineering, what do you do? So basically, this approach is like there are two approaches: general approach and the special approach. Maybe I'll come to that in some time. Yeah. Then one like for anything in life, you should be clear about your objective. So objective of learning this industrial engineering course is essentially to increase the productivity. I mean, everything boils down to this. So, and now this thing, when you say productivity, everything lies in this word. What do you mean by productivity? So, essentially, whatever you are producing at current levels, you need to upgrade. You need to do better, and this is a iterative process. It is not a one day job. It's a continuously evolving process. So there are different ways of increasing productivity. First is to decrease non-productive activities. So basically, I mean, one could argue that this is quite common sense, that if you want to be productive, just reduce the non-productive activities. But the catch is when you are making something, it is not necessary that you will be able to identify that there are some activities in your whole process where you are doing some non-productive activities. So therein you need the help of tools offered by this course to understand, first of all, to realize that there are some non-productive activities or less productive activities and you need to improve on them. So that is first. Then the other could be to increase, the up arrow represents increase utilization. So for example, if you have a let's say if you have a factory and there is one machine in your product line, that machine is currently operating at, let's say, 50 or 60% efficiency. But to increase the productivity of your whole plant, if you can increase the effectivity of a particular machine by, let's say, 10% or 15%, that itself will result in the overall productivity increase. So that can be one approach. And one more thing, one more thing you can say is to reduce waste. So when you say reduce waste, it also includes recycling and all. So what happens, for example, uh, when I was working in the industry, I was working in a soap manufacturing plant. So when you make soap from using a dye, there is a, let's say, 10%, 20% material which is scrap. But ideally, that is soap only, but not in the form of the soap that you see. It's just in the form of rod, or big lengthy rods. So what people usually do, that 10-20% which is discarded in the dye, they just put it back in the mixer, and that's how they improve the efficiency. So these are more or less the objectives of what we do. Then there were multiple tools and techniques that were introduced briefly, actually, uh, at this point, it will be not a wise decision to go into these, because in the due course of this course, you will be introduced to important tools and techniques that are, essential for fully understanding how to do, how to optimize and, increase productivity for various type of industries. So, but I hope you have, gone through the lecture in which these tools and techniques were briefly discussed by professor. If you have just understood what it is briefly at this point, that is sufficient. Maybe in the later course, we'll be going deep into this. Then, yeah, I think after this, just let me, yeah, then there were some chronological developments. I mean, I don't know how many of you are fan of history, but when you learn about anything, any subject or anything in life, uh, it is good to just go through the history of that particular thing, because what happens, it is like, I mean, there are very sharp or brilliant minds in our history that have worked on these concepts or these courses, and today what we learn is the conclusion of their work. So it is, I mean, sometimes history can be boring, but it essentially gives you the picture of how the things that we use today are there, like who first thought of it, then who improved on it, etc., etc. So I think there is one important name, Adam Smith. I think uh, in this course there is a book written by him, Wealth of Nations, is important for this course. You need not go to through the whole book because it's very old book and you'll not understand the English. But you can just read abstract of it somewhere online. It will be available. And maybe I'm digressing, but Adam Smith, I think he wrote one important book regarding the markets as well. I personally like that book very much. Anyway, so coming back to our course, there is there was one mechanical guy. Uh, I mean, I think he was engineer. He was not an academician when he introduced or he invented steam engine. His name was James Watt. So that guy started this industrial revolution in its true sense by the invention of steam engine. There were many others who later contributed to this field, and the mechanical field itself was started there. So that were some of the important contributions. Then, according to, like, as the time passed, there were other brilliant minds like Taylor, Gantt. Gantt charts are very important. I hope you have come across this term in your undergrad somewhere. If not, you can just Google it. It's basically activity versus time graph in which you schedule different activities for a particular set of machines or particular set of jobs or workers, so that your overall utilization is optimum, or you can say maximized. Then there was Gilbreth, Emerson, Tippett. We will not have time to go through each of them. That will take a lot of time. So, yeah. Then the objectives that I have listed here, 2, 3 objectives, they are very general. So when it comes to a particular industry, let's say if you are working in chemical industries, then it becomes quite specific to that industry, and then the tools that you use or the procedures, etc., etc., the standards that commonly use, the vision and the mission of that particular organization and particular sector, the long-term vision, short-term vision, all those things become specific to that industry. Then you take help of industry experts if you are not able to figure it out on your own. So those objectives are industry specific. So we need not go into that at this point, but just keep in mind that when it comes to your particular industry, the tools that you use, the objectives that you set, and the resources that you have are different. They become quite specific. Yeah, then there is, an important, what do you say? Uh, there is one concept like, uh, functions of industrial engineering. What are the functions that industrial engineering can help you with? So there is one, there are many of them. It's not easy to just list them down and hope that it covers everything. But I'll just go through whatever professor has discussed in the class, so that it will be helpful for our discussion. And first was the plant design and location. I think some of you have experience of working in or currently working in manufacturing plants. So essentially, the first question is, let's say you are a company CEO, or the boss of everyone in that company, and you want to put up a plant. So how do you, first of all, why do you put up a plant? Usually it is to cater the increasing demand. Then where do you want to put it? So that's where the selection of site, there are some countries in which you get logistic benefits, but then their taxation will be higher. Whereas on the opposite side, there are some special economic zones in particular country where the taxation will be lower, but the cost of bringing raw materials to that location, as well as taking the completed product, goods or services to the desired end location, that logistics will be difficult. So all these complications will come in. One important factor is the manpower that you need, the skilled labor that you need for any plant. Is it available at that location? Then it comes to economics. The location of the plant, if it is in very posh area of a metro city, it will be very uneconomical, because to acquire that land itself, you'll have to pay a hefty fees. So that's why usually industries are, not in the main cities. I mean, not the current ones. There are some plants like Tata's and all who are in posh Bombay area, but they were very old. So at that time they procured the land cheap, and now they are using it. I'm not talking about that part, but let's say we are talking about right now, 1 or 2 years back. Then there is a question of, let's say you finalize the location, you understood everything, you have studied everything. Now it comes to, what do you want to do there? You'll have some end goal in mind, that, for example, you want to produce certain type of product. So then there is broadly 2 categories are there. One is which we call usually as a mass production, where this fast moving consumer goods industry are there, oil industry is there. So essentially their products are, for these type of industries, the output, the quantity is very important, because their demand is very high. So there you opt for a process layout in which you have a product lines, in which from raw material, you put raw material at one machine, it undergoes various processes in the same production line, and in the end it comes out as a finished product or finished goods or services, whatever it is. Mostly it will be goods, because you are essentially talking about factories. So one example, as I told you earlier, is example of soap that we usually use, for example, Lux, Lifebuoy. So that type of products are, for those type of products, you need to have a layout of plant in certain way. That will you cannot have a distributed layout for mass production. That will be very bad idea. Distributed type of layouts will be beneficial for a particularly specific objective. For example, let's say you want to make a machine which maintains certain temperature of the temperature of any objective at a constant temperature, which we usually called as a chiller, recirculating chillers. So there you need heater, then you need VCRS, cooling assembly, electronics to control everything. So it is an amalgamation of 2-3 types of different jobs. So there you don't go for process layout, because you don't need to mass produce it. These are quite specific productions. There the demand is there, but the quality of the product, the end finishing of the product is quite important than the quantity. I missed one example of the process layout, which is mass production is the automobile industry. So there is very interesting video on YouTube. Maybe you can go later. That when this usually we call Henry Ford as the father of automobile mass production industry. So you can just go and see some videos are there on YouTube that when they started, it was quite a long time back, how they were doing it, and then you go and check in the YouTube itself how today's automobile mass production is done. There you'll realize that over the period of this 100 years or so, how things are improved. And nowadays, I think if it is a two-wheeler, I think within 1 or 2 minutes they produce one two-wheeler from start to end. So that type of advancements are there. Anyway, and let's say you design what type of layout you want, and that's how you start the production. Then it comes to the improvement, because initially whatever you are producing, it will not be optimum efficiency, because usually in the initial try your sole objective is to get things running. But as the time progresses, you understand things better according to that plant layout, according to the labor that you have, and other important factors like weather, etc. So based on that, then you start improving the various processes and functions. Processes are related to the production line, and functions are related to the labor, human resources that you have. So that's how you start. Then coming to the human resource part, in any organization, management and operation is a very crucial thing. So that part was also covered by sir in the class. Then the production planning and control, this I personally have witnessed for a sufficient amount of time when I was in the industry. Basically, I was intern under a production manager. So each manager gets a monthly goal of what quantity they need to produce. I'm talking about mass production here. Then they divide it into a weekly categories, whatever they have. Let's say they want to produce X amount of units, number of units. Then they'll divide it according to the current status. Because if there is a national holiday or local holidays for some festivals, during that week your production will be lower. So you need to compensate it, by using other 3 weeks like that. So that's where the scheduling part comes into picture. Then there is coordination. Then there are cyclical variation according to the seasons. For example, in particular season, let's say if you are a apparel industry, in winters you need woolen clothes or jackets in higher quantities, whereas in summer you need silk clothes or light clothes. So you need to plan accordingly. In India, there is a important factor of festivals. I don't know if you have seen this or observed this. During the festival of Diwali, it is considered as auspicious to buy new things like car or gold. So you need to prepare. If you are an organization catering these goods to the end customer, you need to have a sufficient inventory at the end level. So all those things come under long-term, short-term strategies for production planning. And control means quality control essentially. So you need to have some standards. There are some standards for quality control. Six Sigma, you might have heard. But nowadays people have moved on to even stricter quality control measures. Maybe we'll discuss that later. Then one important aspect is inventory. Because the thing is, inventory is a very critical topic for any industry, because if you have a lot of inventory, there is an inventory cost associated with it that you need for maintenance of it. But if the inventory is too short, your production line will suffer. So it's it's a very delicate balance that you have to maintain when you are dealing with inventories, and there are different modules. I don't know, maybe one model that is coming to my mind is economical order quantity. that is EOQ they call. These are very simple models, but nowadays the models have evolved and quite complicated things are also there. People are using, artificial intelligence, etc., machine learning, all those things for inventory control and other production related things also. So things are quite rapidly evolving in this field, and you should know accordingly if you are targeting for this type of jobs or careers in this type of industries, whatever it may be. So I think now I have briefly covered what happened in the last class. So what we'll do, we'll just take some questions. I don't know how many of you are still there. Just 1 second, I'll just check. Yeah, Ganesh has raised his hand and he put it down also. Ganesh, did you want to
Yes,
ask
sir.
something? Yeah.
I think you stopped the screen sharing, so we can't get some notes. Sorry, scribbling that you have done.
Don't worry, Ganesh. I'll share these notes with the NPTEL team and maybe you'll get it directly as a PDF later.
Yes, sir. I just asked you because we get some proper understanding while you're getting some writings. That's the reason, not for the notes. Thank you so much.
Okay. Yeah, actually, this assignment questions we'll write down and discuss, but the other part was mainly theoretical, so that's why I just went on a talking spree. Anyway,
Yes, sir.
I hope.
I could understand that.
Yeah, I hope it was the broad introduction was helpful for all. Now let's not go there again. We'll just dive into the questions. So yeah, first question that I have is, let's say I have an industry in which I am producing, I am using sugar cane, and I am producing, let's say, sugar. So what type of industry is this? This is the question. I'll just make a column for answer. So can any one of you quickly answer this? I hope this should be easy to answer. Yeah, who is this? Actually, I'm sharing my screen, so I'm not able to see. 1 second, I'll open
This is
it.
Mohammed Khalid.
Yeah. So
MK
yeah,
Ansari.
yeah.
It's
So
a
your
secondary industry.
okay. So MK, your first name is Mohammed, huh? Hello.
Yes, yes.
Okay. Is it fine if I call you Mohammed or MK?
Yes,
MK is
course
fine.
not.
MK is fine. I think MK is even better.
Any sir.
Yeah, so yeah, now I have opened it in my laptop also, so I can see who is asking the question, answering the question or talking. Anyway, yeah, so the answer is correct. It's a secondary industry. So if I am making, I'm producing sugarcane from natural resources like soil, water, etc. Fertilizers. That is primary industry, which is essentially agriculture, sugar producing industry. And then you are taking this sugarcane to a sugar mill or factory where you produce sugar. So this is a secondary type of industry. Okay, we'll take some examples because this is actually quite important for this week's discussion. Yeah, so let's say, what type of example should I take now? Yeah, let's say, my company is offering insurance for certain demographic. So what type of industry is this?
Tertiary industry, sir.
Yeah, tertiary.
Yeah, it is a
So
service-based industry.
yeah, correct. So this is tertiary industry. Actually, matlab, if there is any service that is offered, most of the time it comes under tertiary category. So that is one hint that you can remember for future reference. Then let's say, so I'll take one example which I am quite familiar with. So let's say this is I'm producing a palm oil from seeds or palms, whatever fruits are there. So what type of industry is there? Is this?
It is also one secondary industry, sir.
Uh, yeah, this is a secondary industry. Because when you produced the oil producing seeds, that is a primary industry which depends on natural resources. Then you produce palm oil from it using some chemical processes, so it makes it secondary. Now let's say I use this oil, I mix it with caustic, and I make a soap. So let's say I have a factory in which I make soaps from palm oil. So what type of industry is this now? This is quite tricky, I feel.
Same, sir, I think secondary industry.
Wouldn't be a tertiary industry because it is taking resources from secondary and using it for delivering goods, right? Is it not tertiary, or is it secondary? Anybody is confused in this?
No, sir. Tertiary means service providing. Here,
Yeah.
I think manufacturing only. So it's become secondary, sir, maybe.
Yeah, so the answer is correct, but the explanation could be improved upon by saying the palm oil production industry is different, soap producing industry is different. So for soap production industry, the palm oil acts as the raw material, and it is not always necessary that raw material should come directly from the natural resources. It can be processed goods also. So this is also secondary industry. I think, let me just think for a second if I can ask anything else from this. Yeah, so now let's say I have produced the soaps and I am transporting finished soaps to, let's say, warehouse. So what type of industry is this one?
That's the reason.
Why?
Industry, sir.
Why is it secondary or tertiary? Anyone can answer?
That's the reason.
Okay, but why?
Tertiary. Because, sir, we are producing soap. It becomes secondary. Then actually it is finished product, sir. And now we are transporting to warehouse.
Yeah, so basically transportation is a service, and
Service.
yeah, so essentially since we are transporting a finished goods to the warehouse, we are providing a service to the soap manufacturer, and therefore this comes under tertiary category. So yeah, I think we have covered basically most of the things here. One example I'll just vocally say, because nowadays this IT industry is booming. So uh, uh, let's say, one second, let me think. So let's say I am a company which makes integrated chips, which is ICs for computers or laptops. So what type of industry is this?
Sir, it is a tertiary industry because raw material is not directly converted into chips, because some middle process is also there which is required for chips.
Oh, okay, okay. I mean, okay, you're going into the deep thing. So let me rephrase the question. Uh, 1 second. Let's say I have a plant in which I manufacture ICs. Now, what is the type of industry is this? Edson is saying secondary. Anybody else?
Same, sir, secondary.
Why?
Here we are manufacturing, right? So that's the reason we are it's under secondary. I think so, sir.
Then what is the primary industries for?
I would say these wise and all the things. Not the primary word. Mm,
I mean, are you getting my question? See, you are saying IC manufacturing is a secondary industry, but then what is the primary industry? Like before IC, there should be some primary industry, right? Sanjay wants to say something.
Yes, sir. It is a. I think it is. It might be a tertiary industries because the raw material is taken from natural resources or somewhere else, and it is then processed to make the raw material for these IC chips, integrated chips, because integrated chips are not directly converted with the raw material which is produced, which is taken from resources, natural resources, because some
Then
middle
what is
process is also there, na?
so?
According to me, I think it is a tertiary industry.
Tertiary.
Tertiary.
Okay. Hmm. Anybody else?
First case, sugar is directly converted into sugar, but that is not the case in here.
Okay, let me ask you one question. Like maybe I'm not the expert in this field, but how do the chips are made? This IC is essentially there is a clean room, right? In which you work on, let's say, very small scales, micron level scales, in which you extract the pure silicon. Mostly, it is a silicon-based chips. So when I write here as an integrated chips manufacturing, I'm implying that you are in a clean room. You are using a pure form of silicon or whatever the base is there, and then you are making it in the form of chips. I'm not talking about finished chips which are ready-made to put in the laptops. That's why I rephrased this. So what I was hinting at this was, let's say, because nowadays we are mostly into the IT era, but there is somewhere, if you go deep down there, there is a natural resource which is silicon or other metal oxides which are used for the base, something like that. I'm not sure 100% here, but in a clean room there is an operator with all the precautions. He or she is making these chips from natural resources like silicon. Now one can argue that the silicon is not in that natural form. So yeah, so this debate can go on and on, but the argument behind asking this question was, sometimes it is not as easy as it looks. see, in case of goods and services, it is very easy to understand. And the examples that you can relate with, they are quite easy. But let's say this IC example. So as Sajjan is hinting, there are many processes after which the IC is finally, is in the form of usable form, which can be used in laptops. So let's not go into that debate. But I think I don't want to confuse anyone. So this can be classified as secondary industry, but if you consider a particular process in which silicon is separated from its natural state and pure silicon molecules are extracted, that will be the primary industry. Now, based on those silicon molecules or atoms, when you do the monolayer or multi-layer deposition, that will be the secondary industry, which gives you IC. And when these ICs are put into the laptops, that is also a secondary industry because it is taking finished goods of some other industry and giving you a good finished good. And when you use these laptops or computers to do, for example, what we are doing, this is tele education or IT consultation or stock market investments or insurances, etc., that becomes tertiary industry. So I think I hope everyone has understood this point. So now we'll move on from this topic. So then there is one question. I'll write it down because you need to put this in the sequence. So I'm using this Roman 1, 2, 3. So there are 3 activities. First is increase utilization of resources. Second is analyze the process. And third option you have is improve methods. One second. To reduce waste. So you have these 3 options, and you need to arrange these answers in a correct sequence to facilitate improvement in productivity. You are an industrial engineer in particular organization. So can anybody tell me what will be the correct sequence?
Sir, initially, I think we will analyze the process.
Okay.
Then we will move to improve method to reduce waste. Then increase utilization of resource. Maybe.
Okay. Anybody else? I have just written down whatever was said just now in the sequence 2, 3, 1. Anybody else has another opinion on this, or everybody agrees that this is the correct answer? Anybody? Ganesh is agreeing with the current answer. I think nobody is denying it. I think maybe the confusion that can come is between the first and third option, because see, this is the general approach that I discussed some time back. So first of all, you need to analyze anything or any process or any method is there. First you need to analyze what is it and where it is lacking or where it can be improved upon. So analysis is the first step, that is correct. Now someone may get confused between first and third option, right? Someone may say before reducing the waste you need to improvise the utilization, you need to increase the utilization, but the correct chronological order will be third and first, because see, when you say utilization of resources, it not only it means the machine related or product line related resources, it also includes the human resources. So that includes training of the workers or training of the management team, etc., hiring experts, etc. So the correct answer is second, third, first. So essentially you analyze, then you cut down the activities which are non-productive, you try to reduce the waste, you try to recycle the waste as much as possible. You need to because there are environments also. If you have a waste product which is causing harm to the environment or the local community, you cannot directly put that into the environment. There are legal consequences, there are ethical consequences. So uh, you know I have worked in industry where it's a soap manufacturing plant. There was no harmful, like no toxic chemical waste there, but still there are legal standards by which you cannot directly dispose your waste water into the ground. You need to process it. There is something called as, I think, ETP plants. These plants use some chemical treatments to convert the waste water into disposable water, and then you give it back to the ground. So so reducing waste is very important, and it not only means the waste that you produced on the production line, it means the waste that you essentially produce in your whole manufacturing cycle. So the correct answer is second, third, first. Now we'll go to the next question. Yeah, one. Okay, I'll write down the question. I have seen your assignment 1 and I know what questions are there. So these questions that we are discussing, that will surely help you in there also. So let's take an example of preferred location for installation of nuclear power plant. So this is, let's say you are a investor, or you are a person who has given the responsibility to put up a new nuclear power plant by your boss, and you need to finalize the location. So you have, let's say, these options. One is outside a metro city. Second is near to a let's say what should I say, near to a forest reserve. Then the other option could be desert area. Then other option could be offshore. Offshore means everybody knows offshore.
Yes, sir, near the sea.
Yeah, so sometimes when you discuss the wind energy, wind turbines, sometimes when that discussion comes up, these offshore locations are preferred there. So anyway, coming back to our course, which is the correct option? I think somebody answered as a desert. Everybody agrees with it?
Agreed with desert, sir.
Okay, we'll go one by one. Why not outside a metro city? It is quite I mean, quite obvious. So anyway, I'll answer the question. It's actually slightly tricky. The desert is also not the best
Sir, offshore
location.
is the correct answer.
Okay, we'll see. So outside a metro city, nobody is there, right? Because it will be putting, risk. See, when the nuclear power plant is operating under a normal circumstances, there is no problem. you can put it inside metro city also, at the center of the city. But I think everybody understood when the some natural disaster occurs or artificial disaster occurs, natural disaster, let's say tsunami or earthquake, something like that, or floods, or artificial disaster is war. This Russia Ukraine, you might have heard they are targeting nuclear power plants in Ukraine. So this location think from that angle also. Don't just think that it's outside a metro city the land will be costly, the traffic will be there, so plant workers can have issue there staying, etc., etc. That is a considerable option, economical option to consider, but think from the emergency point of view as well. For example, if the nuclear power plant is under attack, so what will happen there? So metro city is big no, because it will be costly also putting a plant there, and it will be risky also in case of some disaster, because the lives of many people will be at stake. I hope many of you have seen this Chernobyl documentary on Netflix. There you can see the effects that it has when the nuclear power plant goes out of control. So yeah, outside metro city is a big no. Then why not near forest reserves? Because the land will be cheaper there. There is no human intervention there. So why not forest reserve nearby? What is problem there?
I think it disturbs natural habituals.
Yeah. So I think what you said is correct. First of all, it won't disturb the natural habitat in a normal setting, because I don't think nuclear power plants are that noisy. But in case of extreme incidents, if there is a nuclear waste leak or some radiation leak, so that will affect the ecological biosystems there quite drastically. And since there is no human intervention, you may not even realize it when it is happening. So you will realize it quite late, when the damage is already done. And once the nuclear damage is done, it's forever. Like for in human terms, it is forever. So yeah, near forest reserve is also no. Then how about desert? What is the argument for desert? Anybody wants to put it in the desert? No one. Someone said desert. I think Edson was there. Anyway, so yeah, desert. It's actually the best option as far as I am concerned, because first of all, it's quite low remote. There is very less human as well as animal or environmental species interference there. That's why if you have observed many nuclear tests that are done, they are generally done in desert. So that is one thing. But the issue that I see with the desert is, see, if you understand the nuclear power plant, you need cooling water, because when the nuclear rods are very hot, you use that heat to convert water into steam, and then you use that steam to drive the generator or turbine. Then you put that mechanical energy into the generator, and the electrical energy is obtained. But that steam condenses in the turbine, but it is quite hot and at some higher pressures or something like that. So you need to cool it down and reuse it again. But how will you cool down the steam, or let's say water vapor mixture, in desert? So what happens usually, if you are going to put up a power plant in desert or a very remote location, one more necessary condition is that with access to river or dam nearby. Without this, without having a water reservoir which can cool down the steam, you cannot put a nuclear power plant in desert. It won't work actually, because the ambient temperatures are very hot because it is a desert. So it won't work. One can suggest a closed condenser in which you don't need much amount of cold water regular basis, but still you need some sort of cooling source nearby. In case of emergency also, you can use this to cool down the nuclear rods, etc., etc. So this is a catch here. You cannot just say desert. You need to think of that also. Then the fourth is offshore location. I think Sajjan said this is the best option. I agree. This is away from human human habitat. It is cheaper also, I think. I mean, initial capital cost will be higher, but the land acquisition cost and all will be next to nothing. But the problem is there. The problem that I see in case of offshore location is, in case of let's say tsunami, or some sort of sea related calamity is there, what happens then? I don't think any offshore plant can survive tsunami. It will have strength, mechanical damage, etc. In that case, it becomes quite dangerous, because if the nuclear waste or radiation is leaked into the seawater, nobody knows where it will go in future. So, according to me, the correct answer is desert with access to a water reservoir nearby. So this, I'm taking a lot of time to explain all this. I mean, I could have just said the desert is the correct answer, but okay. Ganesh wants to ask something. Ganesh, go on.
Yes, sir. So my doubt is that uh, do this nuclear power plant comes under secondary industry or the tertiary, sir? Because I asked this, the thing I said tertiary because it provides the service right away from the plant, right? So that's the thing.
Okay. Okay.
So I'm confusing confusion between these two. Is it a secondary or a tertiary?
Yeah, I think this is actually the same confusion which was there in this integrated chip example. See, don't look at the nuclear power plant as a single process or single entity, because nuclear power plant itself is a big entity. It has multiple processes. The last end which you are describing, where you send the electricity to the distributor, that is a service. So that process can be considered as a tertiary industry, which is a transportation of electricity from factory or the plant to the distributor. But let's take the other extreme, in which you are having a nuclear reactor for which you need nuclear material in certain form, certain shape and sizes. So it is not exactly a primary industry also, because you are not harvesting the nuclear material yourself, but you are taking it from some industry which has done that for you. So essentially, it is like if you put gun to my head and ask, it is a secondary industry, but that is not factually correct, because it has a lot of aspects. Usually, when it is like earlier examples, when I said sugarcane to sugar, it is very easy because it's single process. But when I give an example of that integrated chip or this nuclear power plant, it is not that straightforward. So nuclear power plant, don't look it as an industry. I understand nuclear power generation is an industry and you can get confused there, but you cannot give one answer when the entity that you are analyzing is that complicated. So I hope I have given you some clarification. If
Yes,
anybody
sir.
asks, yeah, if anybody
Yeah.
asks this question, let's say in future, if you are appearing for any interview or somewhere, and if anybody says what is nuclear power plant, which type of industry, just you can reply that, sir, it has many processes involved. And if you can just clarify which process you are talking about, then I can answer the question. Because you cannot just say it is a secondary or tertiary.
Sir, can I conclude that it is a combination of industries?
Yeah, I mean, not industries, you can just say it's a combination of processes which in itself are industries. I mean, can be industries because power, electricity, transportation is industry itself, right? So, yeah, I mean,
Okay,
what you said is also okay. That is okay.
combination of systems.
Pardon?
So can I call it as combination of systems which involves different types of processors process?
Yeah, that would be logical, but let's say this answer you can give it in interview, but if it is coming in, let's say, GATE exam or somewhere where you have to select one option, I don't think tertiary is the right option. In that case, you can go with secondary if you have to choose.
Definitely, sir. Thank you so much.
Okay. Yeah, so I think we are 8:15. We have crossed the 8:15 mark. I'll just take the class till, let's say, one or two more questions because 8:30 will do. Other than that, after that we can just stop for today. Anyway, let me take an interesting question. Okay, yeah. So this is also quite interesting question. Let's say you are putting up you have finalized a plant location. Now you want to decide what type of plant you want to put. So the question is related to that. Actually, it's let me just think of the options. I know what question to ask, but options are there. 1 second. Yeah, so let me phrase the question this way. Multi-story building is preferred for the manufacturing of. So you have examples like, let's say, airplanes. Second example could be let's say automobile production line. Third example could be since nowadays this industry is also quite in focus, toy industry. And fourth could be let's say turbine blades manufacturing. So you have these four options, but you have a limited space to put up a plant. You cannot have the space that you want, the full extent of it. You need to manage with the smaller space. So if that is the case, what is the correct answer according to you? Can anybody start off the discussion?
Sir, see small toys.
We'll go one by one. Why not airplanes?
Because of heavy machinery and heavy equipment.
Okay.
Automobile is also same, sir. It required production lines. I mean, with heavy machinery, a lot of process over there.
Yeah, so like let me just explain the airplane wala thing. See, airplane is itself a very big. Yeah, Edson, you are right. It's a small toys industry. but let me just give a brief commentary on the options. Airplanes is itself a big component. It has multiple systems that go into it. So, if anybody has seen any documentary on airplane or airplane crash investigation, you could observe that they have a big warehouse or that type of area where they have usually one hanger will be there throughout, so that they can hang these big parts, and when they want to assemble they can just move the hangers. Because if you have multi-story building for airplanes, one risk is, as I told you earlier, if there is any natural disaster like earthquake or something, heavy parts can fall directly at the bottom if they are too high, and that is a very serious hazard or serious risk that everybody working in the plant will have. So that's why for airplanes it's never, I mean, it's actually very trivial, but it's never, I mean, never go for multi-story building. Coming back to automobile production line, see, automobile production line is a process industry. I mean, it's a manufacturing line. There is a production line, continuous line is there. So how will you put a continuous line in a multi-story building? You need some area in which you can, go in one direction till a longer length. So for automobiles and all, you don't need stories. Multi-story buildings are not required at all. You need a longer length or longer dimension production lines. Then turbine blades manufacturing, again, turbine blades, if you know, they are also very long and very heavy also. Plus, turbine blades are very delicate. You cannot have, structural damage, very small structural damage also to turbine blades. So, because if you damage the blades, and I'm not talking about, big damage, I'm saying, let's say there is one small crack when it is, let's say it fell down and it hit the ground and there was a very small crack there. So those are very risky for turbine blades, because when they operate, when they rotate, they have centrifugal forces acting on those blades, and if there is a crack, crack propagation will never happen if there are compressive forces, but crack propagation happens very fast when there are tensile forces, which are, for example, centrifugal forces. So so turbine blades, actually, in case of turbine blades, the transportation of turbine blades is very important. For example, I want to put up a wind turbine plant on top of a hill where there is, let's say that hill is 1 kilometer in height from sea level, and only one small road can lead to the top. There is no proper road also. So the question there is, how do you transport turbine blades to the top of the hill? First of all, how do you put it down? How do you put it up the long shaft? One can argue that, let's use helicopter. Let's tie the turbine blades to the helicopter and take it to the top of the hill. Okay, we do that. But how will you put it down safely? Because as I told you, it should not crack. There should not be any small damage. Let's say you take care of it. Okay, you somehow put, let's say, 100, 200 people there, and they took care of that. But now you have to mount it on the top of the, that main structural support is there, right? That rod, the big rod on which 3 turbine blades are mounted on the hub. So yeah, I think we are digressing, but turbine blade transportation is very interesting challenge. Anyway, coming back to this question, small toys, yeah, that is the correct answer, because small toys are light in weight. Even if they fall from 4th story to the ground floor, the chances of serious injuries are low. They'll be mostly made up of plastic, since they are toys. Usually they are light. Plus, the small toys is not like production line. You can divide different processes and put them on each floor, something like that you can do. And that's how you can save money for putting up a big plant with single story as compared to the multi-story plant with smaller surface area, ground area basically. So that way you can reduce your initial capital cost as well. So these are the factors that you should consider if you want to design a plant. Ganesh, go ahead, ask the question.
Yes, sir. So a second before you discussed about how we transfer these plates up onto the hill to the peak. So I got this ridiculous idea. Could we just have these trolleys where tourist people get over to the hill, right? Can we
Uh,
do that?
No, actually the challenge there is turbine blade is a single entity. It is not multi-component thing, okay? Because you don't want cracks in anywhere. So one turbine blade will be at least, depends on what type of energy production you want, but they are very long. And let's say you put it on trolley and you're taking it up the hill. What happens? The road that leads to the top, usually it will have sharp turns somewhere. So if you put a turbine blade on a trolley or let's say truck or something, you cannot take a turn without getting the turbine blade damaged.
Sorry,
So
sir. Sorry, sir, for interrupting. But I'm saying that these cables, sir, like in some hilly tourist areas, people get
oh,
there to the top.
uh, that cables, they you
Yes,
just
sir.
sit in, they take you to the top. Uh,
Yes.
Interesting idea, but can those cables take this much load? Because turbine blades are quite heavy as well. If they can, uh, someone can try it, but again, when it reaches to the top of the hill, uh, first of all, it should not hit any cable or any structure that is supporting the cable while in the process of transportation. So yeah, it is a good idea, and I think somewhere it can be implemented also. But more practical way is to put it on the tie it to the helicopter and to take it, because that way it is quite fast, quite safer, and there is a chance of blade damage is quite minimal. With I'm not saying the damage chance is not there with helicopters. It is there. Let's say you're taking it up, using helicopter, and let's say rain starts or heavy, wind starts. So those things are there, but this cable line is idea. I mean, we have to check the strength of the cable and what is the end arrangement, all those things.
Yes, sir. What is the better place for this type of manufacturing industry that produces turbine blades with this huge, massive loads?
Usually, the location should be you will need a large ground area. So the cost per square kilometer, or whatever is the unit of distance or area that you are using, cost should be lower because you are going to need a larger area, and that happens in remote locations. You cannot have turbine blade manufacturing plant near city or costly area. You'll have to go to the cheaper area, but you cannot go to the forest, because as I told you, if you manufacture blades there, you need to transport it, right? So
Yes, sir.
uh, usually it will be somewhere in a plateau type of region where the road connectivity is there, proper connectivity, electricity, water, all those things are there, because turbines are made up of metals, right? Essentially. So uh, the things that are required for this machining equipment, that should be available. The area should be cheaper. Uh, the transportation should not be very costly from that location to the desired locations. It should not be a very hilly area, uh, that type of thing. So yeah,
Thank you, sir. Yes.
yeah, okay. I think it's 8:30. Should we stop or should we take one more question? I'll leave it up to you guys, because uh, I think more than me, you are you are the ones who are suffering. Anyway, So
One more, sir, please.
we'll take one more and we'll stop. Okay. So yeah, we'll talk about the organizational structure here, because that was also discussed in the question in the this week's discussions. So let me take one example. Tall organizational structure has, one second. First option is, I am using the downward arrow to represent low or less. So less number of layers and large span of control. Okay, this is first option. Then the second option is just ulta of this, large number of layers and large span of control. Third, it is just a permutation and combination of these arrows now. Large number of layers, but lower span of control or limited span of control. And the fourth one will be limited number of layers or lower number of layers and limited span of control. Sorry. Yeah. So first of all, Ganesh has given the answer, which is 1. So Ganesh is saying tall organizational structures will have lower number of layers but higher span of control. Huh? Tricky. Anybody
Sir,
else?
sir, I think 3, sir. Large number of layer and lower span of control, because it's tall organization.
Okay, now we have another option, first and third. Anybody is going for second or fourth? Okay, we'll just briefly discuss this. When you say organizational structure, I think everybody understands how the management.
Central tall organization is the same as centralized organization.
Yeah, you can say that way. It is centralized. I mean, like tall, you can compare with the flat. I mean, you are mixing two things. When we say tall, the opposition is flat, and when we say centralized, it should be compared with decentralized. But in a general sense, you can assume the tall organizational structure as centralized structure. If you assume that, what is your answer?
Okay, thank you.
Pardon, Edson?
Thank you.
Oh, okay. We have Perumal. Actually, Perumal, you came at the last question. We are about to close. So anyway, since you are here, just listen to this commentary. So yeah, when you say tall organizational structure is essentially, I'll just draw a diagram. I'll give you an example. So when I say it like this. So can you understand this diagram? These are this will be the top boss. This will be the general managers, GMs generally we call them. These will be the regional managers. These will be the divisional managers. Then you come down, you get executives, and finally at the bottom you'll have factory employees. So essentially laborers, which are doing the mostly the physical part of it. This is typical tall organization structure. So when I say tall, I mean this type of structure. So now, can you just think about the answer that you gave before this? Now, see what the options you had was, will it have, let's say, first talk about number of layers. Will it have more number of layers or lesser number of layers? Anybody?
More number of layers.
Okay. Everybody agrees on this? Okay. Now, yeah, and you are right. There will be many number of layers. Now let's come to the second part, which is called as the span of the control. So essentially, what it means, uh, uh, what it means is span is like, see, this tall represents the depth, the number of layers, one by one. Span represents the width. Let's say this. So for each layer, let's say this person, which is I am highlighting with a black thing, he has 3 subordinates as shown here using this arrow. So he has a span of control of 3 employees there. So typically what happens, let me do one more thing that will be very easy to understand. Let me draw a flat type of organization structure. Then you can clearly understand this span concept. So flat organization, as the name suggests, there will be one person at the top, but he will have not 1 or 2, but he will have, let's say, 4, 5, even 6 subordinates, and each one will again have, let's say, 3, 4, like that. So the organization structure will end here itself within 2, 3 layers. They won't have the tall structure like this. So, and it may happen that not even like this guy may not even have a single subordinate. So this is a flat type. So in flat type, what is there? Number of layers are few, but the span, which determines span of control on each layer. So here you can see, right? So this guy, the top guy, has span of control over this many people in one layer, and usually here the span of control will be higher than this tall organization. So here span of control will be lower. So this will answer your question. The answer will be the third option. But more than the answer to the question, I think it is important to understand what tall and short means, tall and flat means. So can anybody tell me what are the advantages of tall organizational structure? 5 more minutes, we'll stop now. Anybody? Advantages of tall organizational structure?
Accountability and responsibility will be, sir, particular person or subordinates.
Okay.
Only 2 persons will report him. Only 2 persons are going to report him. While your flat organization, number of persons are there, which have to report to the boss.
Okay, Sanjay has given the answer. Edson, what were you saying? Hello.
I think so, sir.
Okay.
It's a tall organization is difficult, but maybe however difficult it is, but people can control less number of people. The bosses could control, have a good control. So that's the thing.
Yeah. So I'll just give you a brief answer to this. In tall organizations, the decision making is done by a very few top management level people. That is good and bad also. That is good because the decisions will be very quick, and the decisions will be in according to the strategy of the company or mission or vision of the company. It is bad because if those decisions are not good for the company or the employees that are employed in this company, then the morale of the workers or the lower level employees will be hampered quite aggressively, and it will reduce your overall productivity quite severely. So that is the pros, those are the pros and cons of this type of organizational structure. Now coming to the flat organization structure, here since there are not many layers and decision is taken by multiple multiple employees on a particular layer. So what happens here, uh, people at the lower levels can also get say in taking the crucial decisions for the organization because there are not many layers. So the advantage is in this case of in this type of organization, flat organization, usually the moral of the employees is good, is motivated. They are motivated. They take initiatives. Leadership qualities, accountability qualities are developed quite well. You will have a very good and reliable workforce. But in this type of organization, the decision control is not with a small group of people. It is like a democracy basically. So it will take a lot of time, or uh, the things that are not uh, priority for the mission or the vision of the company, but you'll have to give time to those things as well. Like I mean, the primary objective of any organization is to develop, give profits and do expansion, get as much market share as you can. Usually the welfare of employees is secondary priority. I'm not saying it is with everyone, but in case of flat organization, you cannot deny the discussions on welfare of employees, etc. So you'll have to take care of everyone, and then you will have to take care of your company's vision. So that is a basic difference. So I think I have covered moti like broad topics that were covered that in the week one. And I hope this chronological part, I have not taken any question on it, but you can just go through those slides or the videos of that class, and you'll be able to answer the questions in the assignment. Other than that, I think it's 8:45. It's dinner time now. I don't want to affect that for anyone. So if anybody wants to ask anything, you can ask me. Otherwise, we'll close. Nobody's asking, so I'm taking that everyone is okay with it. Yeah, Sanjay, go on.
So maximum things we have covered.
Yeah.
Thank you.
Okay, thank you. So I'll be following this same sort of flow in the next classes as well. First, initially we'll discuss what was covered briefly, and then we'll solve some assignment questions. So yeah, thank you everyone for attending the course, attending this lecture, and staying for such a long time. And let's meet next Tuesday and discuss the next week's classes. Okay. Okay.
Thank you,
Then,
sir.
yeah.
Thank you so much, sir.
Okay, sir. Thanks a lot. Sir.
Yeah. Good night, everyone, and hope to
Thank
see
you
you
so
next
much.
time. I'll be closing the meeting now. Good night. Bye.
Bye.